Good day, ladies and gentle personalities. Today we are going to be doing the proof of the midpoint theorem, the proof of the midpoint theorem. So basically what we are looking for today is how do we go about proving the midpoint theorem. Okay, now what is a midpoint theorem? Now a midpoint theorem is something that is like this. So what it says is that if you've got a line that is drawn in the midpoint, so if you've got a line that is drawn in the midpoint and then here is a midpoint, so that means that this is equal to this, right? And then this one is also equal to this one. So you've got this being equal to this, so this is a midpoint, and then this being equal to this, and this is the midpoint. So if you have a line, which is this one, that is drawn in the midpoint of a triangle, right? Now, there is something that you can say about that line, and there are two things that you can say. Now, what are those two things? The first thing that you can say that this line is parallel to this line, right? That is number one. But not only that, the second thing that you can say is that this line is half of this line, okay? So that is why it is written like this. Ladies and gentle personalities, this is for grade 10 syllabus in the CAP syllabus in South Africa. You must know how to express, how to state this theorem as it is, and then you must also be able to write this kind of thing for yourself so that when you prove, you will know how to prove it. Okay, now how do you then go about proving this? All right, ladies and gentle personalities, my name is Mqondisi Macaba from Thembela Maths Club, a club that helps learners to understand mathematics. If you want to become part of this community, you can go ahead, ladies and gentle personalities, and click the subscribe button down there. There's a subscribe button down there. Please click it, and then if you would like to be notified when a content like this is being uploaded, also click the notification button so that you can be notified. So go ahead if you want to become part of this community, and then click the subscribe button down there. Right, okay, let's get that out of the way. All right, so let's check the personalities. Let us prove this theorem now. Let us prove this theorem, if this theorem is true, right? All right, so now before we prove this theorem, ladies and gentle personalities, we must conceptualize it. We must contextualize it. Okay, so we must look at this theorem in terms of the diagram that is in front of us. So what is it that we are trying to prove? Never ever make a mistake in geometry of trying to prove something that you do not know. What is it that you are trying to prove? You cannot start a car and then start traveling if you do not know where you are supposed to go. Okay, so basically, now let's conceptualize number one. So basically, number one, they say that this line is parallel to this line, so that means you want to prove, so it's RTP, so you are required to prove what? You are required to prove that this line, which is DE, is parallel to what? To BC. This is the first thing that you want to prove. Okay, this is the first one. But secondly, you want to prove that half of the third, half this line, that is drawn, is half of this line. So you want to prove that DE is equal to half of what? Of BC. Okay, so you want to prove this and you want to prove this. So how can you go about proving that? Now, ladies and gentle personalities, if you have to prove this, you will have to construct first. Now, what do you construct? Now, whenever you construct in geometry, you must state that you have constructed, and you must say what is it that you constructed and what is it that came as a result of what you constructed. Okay, so you say construction. So what do you construct? You need to extend what? DE, right, with a line a line equal to it. Okay, and then to produce f. Okay, so what do we then do? Okay, so you draw a line exactly equal to this. Obviously this is not drawn to scale, so you're just gonna draw sort of, okay, so from here to here. Okay, it's gonna end here. Okay, you just draw this line. Okay, now you draw this line and then you produce what? You produce f. Let me actually put a different color here so that we can see that it was a construction. So you produce f. Here's this line. Okay, and then you produce f. Okay, now when you extend this line, you will then you'll produce f, but another thing that you're going to produce is these angles, this angle and this one, and then you must call this one E1. So this is E1 and then E2. Can you see? So now you've got E1 and E2, and then you've got F, and then to produce F, and then E1 and E2, E1 and E2. Okay. And then join C, F. So join a line from C to F. Okay, lovely. Can you see? Join C, F. So this is the construction that you do in order to be able to prove what you're supposed to prove. Okay, now let us go ahead and prove and see if we can be able to prove successfully. So proof of this theorem. So, right? So, first of all, ladies and gentlemen, personalities, okay, we know that AE is equal to EF, right? So we'll say AE is equal to EC, not EF, EC. Why? Because it has been given. This is given. Okay, do we agree? And then look at these two. Can you see? These two are equal, right? So we then go ahead and say E1 is equal to E2. And what is the reason for that? We are given. Okay, and then do we have any other thing else? We've got this side, ladies and gentlemen, being equal to this side, and we know that by construction, remember we said we're going to extend DE with a line equal to it and to produce F. Can you see? So because of that, DE is equal to what? Is equal to EF. And then how do we know that? We know that by construction. Okay. Now can you see? You've got this triangle. Can you see that? Actually, before you start this thing, you must say that in these two triangles, because you are trying to show that these two triangles are congruent to each other. So you say in triangle A, D, E, and triangle what? Triangle C, F, E. Okay, then what is happening here? So this is equal to this given, this is equal to this. I'm talking nonsense. This was not given. E1 is equal to E2. Why? Is because the vertically opposite angles are equal. Okay, not this one. So guys, be very careful in geometry. Don't be taken away. You must always be sober. Okay, I think I lost contact there somehow. I do not know how, but be careful. Those things does happen in geometry. Okay, so because of that, ladies and gentlemen, therefore triangle ADE is congruent to triangle. So triangle what? Triangle CFE. And what is the reason for this? I started by proving the side first and then the angle in the side. So it's side, angle, side. Okay? It is side, angle, side. It's congruence. Now, ladies and gentlemen, personalities, there is, if you don't remember congruence, there is a video in this channel that speaks about congruence. Go and look at congruence so that you can see how you get to these kinds of decision if you have forgotten it. So, but what does congruence mean, ladies and gentlemen, personalities? It simply means that the sides are equal and the angles are equal. All right, so everything is exactly the same. So this triangle is exactly the same as the triangle in terms of in terms of size and in terms of what? In terms of a shape. Okay, so with the eyes of your mind, you can actually take this triangle and put it here and then flip it over here. Can you see something over that? Can you see? Yes. So because of those kind of things, then you've got this angle being equal to this one. Can you see? Aha, because of congruence. So triangle A, so angle A, so A D, now you must put heads in D. DE is equal to triangle what? Triangle E, triangle C, F, E. Can you see that? Because of this congruence. If we did not have this congruency, we couldn't have established this. Okay, so we draw this conclusion from this. So therefore, this is the case, and then therefore, because of that, then you've got this angle being equal to this angle. Okay, so now I want you to look at this and look at it very carefully. Now, if this is then equal to this, now what is happening? Can you see? There is a Z shape here. So if this angle is equal to this one, that means that this line is equal to what? Is equal to this line. Can you see that? This line is equal to this line, but obviously this line extends to this one, so it's the same line. So because of that, ladies and gentlemen, personalities, therefore you have what? So you will have BD being what? Being parallel to what? To CF. Now, what is the reason for that? It's because you've got alternate angles, because it's an N shape. You've got alternate angles being what? Being equal. So once you have alternate angles, remember, if the lines are parallel, then the alternate angles are equal. But if the alternate angles are equal, it simply means that the lines around there are what? Are parallel. Okay, so BD is parallel to BF because of this equity of these angles. Can you see that? So now we have proved the first part. That's okay. You've got, sorry, no, you haven't proved, you haven't proved the first part, because the first part is DE parallel. Okay, so you've got BD that is parallel to CF. You haven't proved anything. Let's continue. Okay, so you only know that, okay, this is parallel to this one, right? Okay, now I want you to notice something as well. This one is equal to this one, to remember. So BD is equal to DA. Now, how do we know that? It was given. Okay, but now this DA is equal to CF. How do we know that? Through congruency. Okay, so BD DA is equal to CF. Why? Since what? Since triangle ADE is congruent to triangle CFE. Okay, so if this, okay, so this is equal to this and this equal to this, so what does it mean by this and this? It means that this and this are equal. So therefore, because of that, ladies and gentlemen, personalities, BD is equal to CF. Now here is a very interesting. So you've got this line being equal to this line, and then you've got this line being parallel to this line. So this condition and then this condition, there are sufficient conditions to show you that this is what? This is a parallelogram. So because of this, ladies and gentlemen, personalities, therefore B C F E is a PAM. PAM is a short for parallelogram. Now why is that? What is the reason? It's because you've got opposite sides being what? Parallel and equal. Ladies and gentlemen, if you have one pair of opposite side being equal and parallel, that is enough to show that the figure that you are working with, which is this in this particular case, is what? Is a parallelogram. Now, because now this is now a parallelogram, let's just quickly try to mark it somehow. So you've got this being a parallelogram, ladies and gentlemen, personalities. So what is that then follows? So if this is a parallelogram, therefore it means that this line is equal to this line. That is a property of parallelogram. Okay, so where is my red pen? Where is my red pen? So because it's a parallelogram, therefore DF is equal to what? Is equal to BC. So this is equal to BC, right? No, even before we get to that, okay, since this is a parallelogram, so you've got DE. Let's start with DE first. DE is parallel to BC. Now, this was this one. Can you see? DE is parallel to BC. That is the first condition being met. So now we're only short with this, but because it is a parallelogram, for the same reason, because it's a parallelogram, therefore you will have DF being equal to what? BC. Remember, the opposite side of parallelogram are equal. And then we know that, so we say, but DF is equal to half what? Half DE. How do we know that? By construction. We constructed it like that. Okay. So DF is equal to DE. So in a place of DE, of DF, you can then replace it with what? With DE. So you will say half. Aibo, it's not half, it's 2 times. I'm talking nonsense. Hey guys, you must be careful. You must look at me very closely. And if you see that I'm catching up nonsense, you must tell me. This is mathematics, guys. Even the teachers can be wrong, so you must watch out. Okay, so you've got DF, which is equal to 2DA. Remember, this is equal to this. So and then because of that, so if you've got the whole of this is equal to 2 times 1 of this one. Okay, so this is what DF is equal to 2DE. So now in a place of DF, you can then replace it with what? With 2DE. So because of that, therefore 2DE is equal to what? Is equal to BC. Can you see? And then when you divide by 2 this side, remember the 2 will cancel this one, right? And then the 2 will also be here. So you will therefore have DE being equal to half BC. Okay, that proves the second part. All right. Okay, so what is happening? You have shown that DE is parallel to BC. You have also shown that DE is half of BC. So those are two conditions that you were supposed to prove in the first place. So therefore say this is what was supposed to be proved. You have proved that if you've got a line drawn in the midpoint of a triangle, therefore that line is one parallel to the third side of the triangle. But not only that, secondly, it is half the third side of that triangle. Okay, so you can say to me, Mr. Machaba, this is a mess. How do I follow all of these things through? Ladies and gentlemen, I will just give you some tips, especially for the exam when you are preparing for exams. So basically, when you look at all of these things, okay, number one, as I said, you must be able to state the theorem, you must be able to draw the theorem, and you must be able to contextualize it and you know what construction. But the most important thing when you are proving, ladies and gentlemen, okay, you must know the construction well, but when you are coming to prove, the first thing that you must prove, which can give you guidelines. So let me just quickly write guidelines, guidelines to this proof. So this proof. Now what is this midpoint theorem? Now the first thing that you must do, prove congruence. Congruence. Okay, can you see this is the first thing that we did? You were to prove congruency. Now once you can prove congruence, remember when you prove congruence between these two after you've constructed, therefore it is easy to then say, to find that this one is equal to this one. Can you see that? So you prove congruency, and then so from congruence it comes that this one is equal to this one. And then so the second milestone that you need to approach after proving congruence, you must then, I think the second milestone will be to prove that, show that DB is parallel to BD. Okay, show that BD is parallel to CF. Okay, so once you prove congruency, it will then lead you to a stage where you can show that this one is parallel to this one. Okay, because once you can establish this, therefore you inherit all. Remember, once you show that something is a parallelogram, then there are properties of parallelogram. Then if you have shown that this is a parallelogram, then you inherit for free those properties of parallelogram. Can you see that? Okay, so you inherit, then you can use them. So this is how you can then show that. Okay, now when you have shown that this is parallel to this one, then you are sorted. And then the one of the milestone also that you must follow after that, so the third one, you must show that, okay, you've shown that this is parallel to this one. Now show that what? Show that BD is equal to CF, because this is a very milestone. So you show that this is equal to this, and then this is equal to this, and then these two will then give you a parallelogram. Therefore, when you have done that, when you are done with the parallelogram, therefore the last thing to do is just to show the main properties. Then from there, this then leads you straight to number 4, which is the main number 1, showing that DE is parallel to BC, and then number 5, that DE is equal to half of BC. Okay, so the first thing that you must try to prove is congruency. Once you prove congruency, just show that these two are parallel to each other, and then show that these are also equal to each other. So when you're able to show those two, then that gives you a parallelogram. Therefore, you inherit for free the properties of parallelogram, which will then lead you to being able to prove this one, and then after that, prove this one. Okay. But ladies and gentlemen, personalities, I think there's just one thing that I must mention, which is very, very important, especially when it comes to mathematics. Ladies and gentlemen, personalities. So what you can do for yourself if you want to understand this midpoint theorem is to do what? Is to actually try and follow. The only thing that you need to see is how I get to my conclusion. Okay, and the reasoning that I used, and you must assure yourself that you agree with the reasoning that I used. Right? Now, after that, don't cram this theorem, ladies and gentlemen, personalities. Do not cram this theorem. So try to understand as much as you can and try to express it in your own way. So take this theorem, you can even write it down like this, and then maybe you can cram it for the first time, but make sure that you understand each and every line and what did I do and what is it that I put as a reason to what I was doing. And then after that, you take your own blank paper and then you try and do it on your own. Now, when you simply do that, ladies and gentlemen, personalities, therefore you are personalizing. Remember, during the exam, you are not going to remember what I said, but you are going to remember what is in your mind or what resonates with the ideas that are already in your mind. Okay, so this is why you must personalize it. Don't cram it, but personalize it. Write it on your own. It's the reasoning. So, like when I mark this kind of a theorem, I just want to see what you say, and I want to see what is the reasoning behind what you say. And that is all. I wouldn't literally expect you to write this proof as it is, because there are many ways in which one can be able to express mathematical arguments. But even so, it is very important. What is most important than all is that whenever you are saying something in geometry, you must have a proof substantiating, you must have a reason substantiating whatever that you are saying. Now, if you have that, therefore, the statement then holds. You cannot have a statement that you can't tell me why did you say a certain statement. There must be a statement, there must be a proof. All right. So, ladies and gentlemen, if there is any questions that you have regarding this proof that you just done, you can go ahead and ask. There is a comment section that you can ask, and also if there is a mistake that you noticed, because I can also make a hell of a lot of mistakes. So if there is a mistake that you identified that I made in this proof, you can also go ahead and let me know that Mr. Makaba, you made a mistake here, and I will be very happy to rectify it. So at the end of the day, ladies and gentlemen, it then turns out that indeed this is parallel to this, and then this is half of this one. Okay, now beside proving it, because obviously proving this theorem is examinable, you must know how to prove it. But ladies and gentlemen, besides that, you must know how to use this theorem. Okay, because you will be, especially because there are some people who are actually looking at this theorem and they are grade 12. You grade 12s, you will definitely use this theorem when you are looking at the proportionality theorems in the grade 12 syllabus. You will need the understanding of this. It will definitely help you so much. It will actually help you to cross so many rivers that you couldn't have crossed if you did not know this. So you must know these theorems. But besides knowing these theorems, all the theorems, ladies and gentlemen, personalities, you must know them and you must know how to use them. You must know how to use this theorem as well, in the same way as you know how to use other theorems. Write them down, know how to use them, and how to cut them across, how to use each theorems in different contexts that you find yourself in. So ladies and gentlemen, personalities, this is Mqondisi Macaba from Thembela Maths Club, a club that helps learners to understand mathematics. And thank you for tuning in. And those who haven't subscribed, please go ahead and subscribe to this channel. Here's a subscription button down there. But other than that, enjoy the rest of your day. And to those who will be writing, happy writings, all the best for your exams. Thank you and goodbye. And I hope that this helps ladies and gentlemen, personalities. I do hope. Thank you very much.